When you think about it, it's obvious that light travels fast. When you turn on a light in a dark room, both the light bulb and the room seem instantaneously lit. Whether light travels instantaneously or has a measurable speed was a question explored in the 1600s.
In the 1600s, Galileo reputedly tried to measure the speed of light. He stood on a hilltop with a lantern, while his assistant stood on another hilltop with another lantern. The plan was that Galileo would open his lantern, and when his assistant saw the light, he would uncover his lantern. Then, Galileo would measure the time between when he first uncovered his lantern and when he saw the light from his assistant. But the speed of light is so fast, and the distance between Galileo and his assistant so relatively short, that they soon realized this experiment could only measure their reaction times and not the speed of light.
Longer distances or more sophisticated techniques would be required to determine if the speed of light were finite. Those measurements were to come in 1675. By that time, scientists knew how long it took Jupiter's bright moons to go around Jupiter. The Danish astronomer Olaus Rømer found that the moon Io disappeared behind Jupiter about 20 minutes later than expected, when the Earth was far from Jupiter in the Earth's orbit around the Sun, compared to the time when Io went behind Jupiter when the Earth was closest to Jupiter. So what was happening? Well, the orbital period of Io wasn't changing, but the distance from Jupiter to the Earth was. It was taking light from Jupiter's moon about 20 minutes longer to reach the Earth when the Earth was farther from Jupiter compared to when the Earth was nearer. With these measurements, Rømer computed the speed of light and showed for the first time that light does not travel instantaneously. Today, the adopted value for the speed of light in a vacuum is 300,000 kilometers per second. Despite science fiction ideas about spaceships that travel faster than light, at warp speeds, physically it's impossible for anything to travel faster than light. But what do we know from our everyday experiences about how fast light travels? Think about a thunderstorm. First you see the lightning, and then you hear the thunder, although they actually occur at the same time. You may know that if you count the number of seconds between the lightning and the thunder, you can figure out how far away the lightning is. It takes sound about 3 seconds to travel 1 kilometer. If you see lightning, you count 1, 2, 3, 4, 5, 6. You hear the thunder, that means that lightning is about 2 kilometers away. So how long did it take light to travel that distance? Only 2/3 of 1,000th of a second. Compared to the speed of sound, at these distances, light does arrive practically instantaneously.